I want to start today with a little mental exercise. It's simple. I want you to close your eyes for a second and just picture the cloud.
Mm.
Just let that image pop into your head. What do you see?
I can tell you what most people see. It's, white, it's fluffy, floating in a nice blue sky.
Right.
It feels a little bit ethereal, maybe, like magic.
Exactly. It's weightless. And that is the image we've been sold for, what, 15, 20 years? That the digital world is this invisible, infinite layer that just sits on top of our reality. It's just there.
Yeah.
But today, we are going to absolutely shatter that illusion, because if you actually go to where the cloud lives, it is anything but fluffy.
It's loud. It is incredibly hot. And it is heavy, industrial heavy. And that disconnect, between the marketing and the physical reality, that's exactly why we're here.
We are doing a deep dive into an article that I honestly think marks the end of an era. We're looking at a piece by Johan Steyn titled AI as a Grid Bully, Who Gets Throttled First?
Great title.
It is. Now, Steyn is a heavy hitter in this space. He's an AI thought leader, focuses specifically on that collision between tech and society, and he's writing this from South Africa.
And that context is so important.
It's critical. It gives him this very sharp, very urgent perspective on what happens when the resources just run out.
And this article is important because it really challenges that famous Silicon Valley mantra, the one, software is eating the world.
Mark Andreessen.
Right. And for 2 decades, that was true. But what Stan is arguing is that the meal is over. Software is done eating. We've now hit the physical limits of the universe. He calls it the thermodynamic trap.
The thermodynamic trap, that phrase really stuck with me. It implies that the bottleneck, it isn't our code anymore. It's not about how smart the algorithm is.
No.
It's about physics.
That's the core argument. Steyn identifies these 3 hard physical walls that AI is slamming into right now. Heat, grid stability, and sovereignty.
Yeah.
And to really get into this, we've also pulled some technical reporting from the Tech Cold War series, just to get those on-the-ground examples of what Steyn is warning about.
So let's walk through these 3 walls, because they paint a picture that looks very, very different from the gloss of a tech keynote. The first one is the most visceral: heat. Steyn makes this point that AI chips don't just use power, they transform electricity into heat at a density that is just becoming unmanageable.
To really get this, you have to banish that image of the clean server room. We all think of a data center as like a sterile, quiet library with blinking lights.
Right.
But Steyn points out that modern AI clusters are more like chemical refineries.
We actually have a source in the Tech Cold War documents, a thermal engineer, let's call her Sarah, who describes walking into the hot aisle of a high-density compute cluster.
Oh, yeah.
And she says it's not a library. She calls it a wall of sound.
The sensory details she gives are just wild. She talked about the sound vibrating your bones. It's a physical roar.
Yeah.
It's the sound of thousands of cooling fans just spinning at maximum RPM, screaming to push air through these racks. She described the air itself as feeling like a soup of energy.
A soup of energy. That is unsettling. But why is it so different from the internet of 10 years ago? We've had data centers for a long time. What changed?
Density. That's the key. To make these AI models, the LLMs we all use, actually smart, you have to crush latency.
Okay.
And the only way to do that is to pack the GPUs incredibly close together. You need the signals to travel shorter distances. But when you pack thousands of chips, each drawing maybe 2,000 watts, into a space the size of a bedroom,
You create a thermal crisis.
you get a thermal crisis. Steyn calls it the heat wall.
And the margin for error in an environment like that must be what? Razor thin?
It's practically non-existent. The technical reports say that if the cooling system fails for just 10 seconds, literally a 10-second hiccup, the chips don't just crash.
They don't just shut down?
They physically melt.
That's
The
good.
solder liquefies.
So we aren't talking about a blue screen of death here. We are talking about hardware suicide.
Exactly, silicon destruction. And this just validates Steyn's argument that traditional air cooling is dead. You just can't blow enough air to cool these things.
It's like trying to put out a forest fire with a garden hose.
It is. It's exactly that.
Yeah.
So the industry is having to resort to some really extreme engineering just to keep the lights on.
I was reading about this in the notes. They're effectively boiling the internet. Is that right?
It sounds insane, but yeah, it's called two-phase immersion cooling. You take the entire server, rack electronics, wires, everything, and you dunk it into a tank of this specialized non-conductive liquid.
And it just sits in there.
And the liquid boils directly on the surface of the silicon. That phase change, from liquid to vapor, it just absorbs massive amounts of heat.
So the infrastructure running our chatbots is literally a plumbing system of boiling fluid.
Pipes, pumps, condensers, containment vessels. It's heavy industry. It's plumbing. And that's the perfect bridge to Steyn's second limit. If the inside is a thermal crisis, the outside is becoming what he calls a grid bully.
I absolutely love that title, AI as a grid bully.
Ah.
It immediately gives you a sense of the dynamic, doesn't it? These data centers aren't just passive customers.
No, they're aggressive. They are violent consumers of power. Steyn argues that AI workloads are bursty and volatile in a way that our grid just wasn't built for.
We should probably pause here and explain the zombie beast concept. The source material uses this analogy, the zombie beast versus the software insurgency. What is the zombie beast?
It's a great analogy. The zombie beast is our current power grid. In the U.S., and definitely in Steyn's context in South Africa, the grid is old copper and steel. It's aging.
Right.
It was designed decades ago for steady, predictable loads. Think of like a refrigerator humming or a factory motor running at a constant speed. The grid has inertia. It likes stability.
And AI is the opposite of stable.
Correct. AI doesn't hum, it pulses. There's a technical term for this that Steyn alludes to. Bulk synchronous parallelism.
Okay, let's unpack that. Bulk synchronous parallelism. Sounds complex.
It's actually pretty visual. Imagine 20,000 GPUs working on one training run. They're like a marching band.
Okay.
In 1 millisecond, they all compute at the same time. Power demand spikes to the heavens. In the next millisecond, they all stop to communicate with each other. Power drops to near zero.
So it's on, off, on, off.
Compute, communicate, on, off, thousands of times a second.
And that flickering demand, the zombie beast grid can't react that fast.
It's worse than reaction time. It creates harmonics. You know the classic trope of the opera singer shattering a wine glass?
Sure, she hits the resonant frequency and it just explodes.
That is exactly what happens here. But the glass isn't a wine glass. It is a multi-ton steel turbine shaft in a power plant 50 miles away.
Wait, what?
If the pulsing frequency of that AI workload, say 30 hertz, accidentally matches the resonant frequency of that turbine shaft, you get something called subsynchronous resonance.
And what does that do?
Torque amplification. The AI training run can physically vibrate the power plant shaft until it snaps in half.
That's terrifying. You're telling me that a piece of software doing math in one building can physically destroy a power plant 50 miles away?
That's the physics of it. That is why Steyn calls it a grid bully. It's not just drawing power, it's stressing the mechanical integrity of the whole system.
It's beating up the grid.
It really is. And Steyn makes a crucial point about context. In a place like South Africa, they already have load shedding. The grid is already on its knees. You add a bullying load like this, it risks total collapse.
This really puts the human cost in perspective for me. The source material had that story about the aluminum plant manager in Ohio. That really brings this down from abstract physics to real life.
It's a tragic story, honestly. You have this veteran manager of a smelting plant, heavy industry guy. He hears a massive data center is being built down the road. At first, he thinks it's great.
Modernization, investment.
Right, maybe better infrastructure for everyone. Silicon Valley comes to town. But then he gets the memo.
He is told that during peak summer loads, his smelting lines, the economic backbone of that town, are going to be throttled first.
Wow.
The priority had shifted. The grid operator effectively told him, we need to feed the windowless concrete monolith down the road, so you need to shut down.
He had that one line that just gave me chills. He said, I thought the cloud was supposed to be light, but that thing, it doesn't want code. It wants gigawatts of raw nuclear power.
That realization changes everything. He realized he wasn't competing for customers. He was competing for electrons. And that brings us to Steyn's third and honestly most political limit, sovereignty.
Sovereignty. Usually when we talk about big tech, it's about market share or antitrust, but Steyn is talking about actual power, like literal power generation.
He's arguing that we're shifting from an era where tech companies are power customers to an era where they are power owners. If you are Microsoft or Amazon, you look at the zombie beast public grid and you realize it's too slow, it's too dirty, and you might break it.
So you just bypass it.
You go behind the meter. This is a critical concept. Normally, if I want to build a factory, I apply for a grid connection. In the US right now, that interconnection queue is 5 to 7 years long.
Which is an eternity in tech time. By the time you get plugged in, your AI model is obsolete.
Exactly. So they aren't waiting. They are engaging in what the reports call a nuclear land grab. We see Amazon buying data center campuses right next to the Susquehanna nuclear plant. We see Microsoft involved in restarting 3 Mile Island.
So they're just running a wire straight from the reactor to the servers.
That's it, effectively privatizing the nuclear supply chain.
But here's my question. If they take that power directly, doesn't that remove it from the grid for the rest of us?
That is the crux of Steyn's warning. Power is a zero-sum game. If a tech giant secures, say, 6 gigawatts of firm, clean nuclear power for themselves, that baseload power is gone from the public mix.
Okay.
But the grid operator still has to keep the lights on for you and me.
Yeah.
So what do? They have to fire up the older, dirtier, more expensive peaker plants, usually gas or coal.
So in a very real way, my grandmother's electric bill is going up to subsidize an AI training run happening inside a private fortress.
Precisely. We absorb the cost and the carbon. They keep the intelligence and the profit. Steyn warns that this crowds out the public interest. A hospital or a school, they can't compete in a bidding war against a company with more cash than a small nation.
The tech giants are effectively seceding from the grid.
They are. And this feels like a shift in the fundamental structure of the economy. The sources use the term techno-feudalism.
Now, that sounds a bit dramatic, doesn't it? Or is it accurate?
It's a strong term, but if you look at the definition, it fits. Capitalism is about competing in a market for profit. Feudalism is about rent-seeking, based on owning the land and resources.
And if they own the land, the data, the compute, and now the energy source,
Then everyone else is just paying rent to exist in their ecosystem.
there was that anecdote about the regulator in D.C. I think that captures this power dynamic perfectly.
The treaty story, yes. So a state regulator is sitting across from a tech executive. The regulator thinks he's there to give permission, set some ground rules.
Standard meeting.
But halfway through, he realizes the executive isn't asking for permission. The executive is offering a treaty.
A treaty. Like a diplomat from another country.
Because when you control your own nuclear reactor, your own global fiber network, your own satellite constellation, you aren't really a company anymore. You're a sovereign entity. Look at the Starlink example with Ukraine.
Right, that was a huge news story.
It was a defining moment. You had a military operation that needed connectivity. The decision to enable or disable that coverage didn't go to the White House. It didn't go to the Pentagon.
It went to one private CEO.
One CEO. He made a decision based on his own criteria and effectively drew the border of a war zone with a software update.
That is mind-blowing when you put it like that. Unelected individuals making geopolitical decisions because they own the physical infrastructure.
This supports Steyn's point entirely. He says infrastructure decisions, who gets the power, who gets the bandwidth, are shaping the future of nations. It's not just about who has the best chatbot. It's about who controls the atom and the electron.
So if we follow this trajectory to its logical conclusion, where do we end up? I mean, heat walls, grid bullies, nuclear land grabs. The tech Cold War source had some pretty wild theoretical stuff at the end about the physical endgame.
Oh, it gets deep. If you accept Steyn's premise that thermodynamics is the ultimate limit, you eventually run into something called Landau's principle.
Landau's principle, we're getting into heavy physics now.
It's a fundamental law.
Yeah.
It basically states that information is physical. To erase a bit of information, to forget something, you have to generate a tiny amount of heat. It's unavoidable.
You can't compute without paying a thermodynamic price.
You can't. And this leads to a thought experiment from Seth Lloyd at MIT called the ultimate laptop. He calculated the absolute physical limit of computation. Imagine taking a kilogram of matter, a rock, whatever, and compressing it until it becomes a black hole.
A black hole computer.
Theoretically, a black hole is the densest possible storage of energy and information. In that fraction of a second before it evaporates through Hawking radiation, that black hole would perform the maximum number of calculations allowed by the laws of physics.
So we are essentially on a path where we are terraforming the planet to turn energy into information, and the theoretical endpoint is a black hole. That is a lot to process.
It is the thermodynamic trap made real.
Yeah.
We're turning the Earth into a computation engine.
Okay, let's pull back from the event horizon for a second. We've painted a pretty intense picture here. Boiling servers, snapping turbine shafts, techno-feudalism. But Johan Steyn didn't just write this to scare us. He wrote it to offer a roadmap.
That's right.
What does he actually say we should do?
He's very practical. He pivots from these massive warnings to actionable steps. For business leaders, his advice is blunt. Audit your energy footprint. Don't just ask, what can this AI do for my revenue?
Ask what happens if the power goes out.
Exactly, because if you're relying on that zombie beast grid, that's a real risk. He says if your resilience plan assumes abundant power and water, You don't have a plan, you have a wish.
And for policymakers,
Transparency and fairness. He argues they need to vigorously protect the public interest. You can't let data centers crowd out hospitals and schools. He says demand full transparency on water and energy impact before these things get approved.
no more trust us, it's the cloud.
No more of that. And I think his message for the rest of us, for you listening, and for us, is really about a shift in perspective. It is. He says we need to recognize that a smart future that is physically fragile isn't progress. It's a vulnerability. We shouldn't just be awed by what AI can do. We should be asking about the cost of the infrastructure that holds it all up.
It really does change how I look at the news now. When I see a headline about some new AI model, I don't just think about the code. I think about the cooling towers. I think about the water table.
You should.
Yeah.
Because as Steyn puts it so perfectly, the future isn't being decided in the cloud. It's being decided in the power station.
That's the takeaway right there. The era of magic, weightless software is over. The heavy metal era is here. I want to leave you with one final thought to chew on. We've talked about these tech giants becoming sovereign entities because they own the power.
Yeah.
If they have their own nuclear reactors, their own satellite networks, their own AI, at what point do they stop needing us? Are we citizens, or are we just becoming tenants on their planet-sized computer?
That is the question of the century.
A huge thank you to the work of Johan Steyn for sparking this conversation. We highly recommend you go read the full article, AI as a Grid Bully. It is well worth your time. Thanks for listening to The Deep Dive. We'll see you next time.